So you've already watched at least one video about naming alkanes, but I'm going to run through a couple of things really quickly that video did not cover and recap a thing or two that video did cover. Alkanes fit the general formula, CnH2n plus 2. That's because every carbon likes to make 4 bonds, so you're going to have a full carbon on all alkanes, all single bonds. Remember, that's what alkane means. So you've been working on memorizing the prefix names and how many carbons that represents. Meth is 1, eth is 2, prop is 3, etc. So there are 3 main ways to name alkanes. Trivial is one way. We won't really discuss rules associated with that because as far as I know, there are no rules associated with that because it's not dependent on rules, it's dependent on several other factors. Common naming is how molecules used to be named before the IUPAC, International Union of Pure and Applied Chemistry, came in and says, we need some rules. So when you hear IUPAC nomenclature, that means systematic nomenclature. Those phrases are interchangeable. So common naming was not covered on the previous videos that you watched, so we'll talk a little bit about common naming now. So common naming often has this iso bit. This is a 4-carbon alkane, so it has the root name of butane, but it's not 4 carbons all in a line like this. This is regular butane. This is isobutane because of this fork, this split. 5-carbon alkanes can also be named with common naming. This has the same little branch, so that's why it's called isopentane. The pentane is because there are 5 carbons in total in that molecule. This is neopentane. It's a pentane because there are 5 molecules in total, and this chicken foot branch over here is the neo. You can see isohexane and neohexane the same down here also. This little split means iso, but 6 carbons in total, hexane. This little split means neo, 6 carbons in total, hexane. Here's the splits that I was talking about, iso, 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 all have that same little fork on the next to last carbon in the line. Neo has a 2-pronged fork, a 3-pronged fork, I don't really know how you want to say it, how you want to count it, but a little chicken foot hanging off next to the end carbon in the line. Iso and neo, common naming. That's silly stuff, naming iso and neo, and it doesn't really make a ton of sense to call them that. So that's where IUPAC stepped in and says, let's come up with some rules. So you've already gone over all the rules of IUPAC. That's not true. You've already gone over a lot of the rules of IUPAC, including this one. But since you have these examples at your disposal, I'm going to go ahead and highlight the main chain in these and give you the full name. Main chain, that. 1 carbon substituent. Main chain, parent chain, this. 1 carbon substituent. As it turns out, both of these are named 3-methylheptane. They're drawn in different orientations, but because you're following the IUPAC systematic rules, the longest chain is the same, and the branch gets the same number, and it's the same branch. So it doesn't matter how you draw these 3-dimensionally or twisted and turned whatsoever, they're the same compound, 3-methylheptane. Some substituents are more clear in their naming, like methyl, ethyl, propyl, but some have branch names that give funny names. This iso, as we just discussed, is part of common nomenclature, but sometimes you will see names like isopropyl appear in IUPAC nomenclature. Let's discuss a little bit further. So if I draw a really long carbon chain, let's add a few groups to this really long carbon chain. If I have 3 carbons all in a line, that's called a propyl group. It's sometimes called an N-propyl group, where that N stands for normal propyl. If I have 3 carbons, but they're not all in a line, they're connected in this fork-like way, that's isopropyl. Just a little thing that will save you some headache down the line. There is not a dash between iso and propyl. There's never a dash between iso and the letter that comes next. So hopefully you can tell that these things are different. They both have 3 propyls connected off of the main branch, but the way that they're connected is different. This one has 1, 2, 3 all in a line. This one has 1, 2, 3, and it's connected by the central carbon. Isopropyl. 3 carbons connected by the central carbon. Okay, what about some others? 4 carbons all in a line. That's butyl, sometimes referred to as N-butyl, where the N means normal butyl. 2 that students often get confused are these 2. This one that has a little fork on the end of it is isobutyl. This one, where the second carbon in a row, second carbon in the 4 carbon chain, is the one that connects it to the main parent chain backbone, that's sec-butyl. There is a dash between sec and butyl. And the final butyl derivative is this one. That's a tert-butyl. All of these have 4 carbons connected to the main chain, but how those 4 carbons are connected is different. You need to be familiar with these shapes and their names. Isopentyl was also on our table previously, but that one is not nearly as common as these that I provided here. All of these branched substituents can be named like this, or they can do their own systematic naming, their own IUPAC rules. Let's see what that means. Starting over here at isopropyl, if I highlight the longest chain that I can on isopropyl, knowing that the first carbon connected to the main chain is carbon number 1, I can highlight a 2 carbon chain in isopropyl. So that gives me the root name of eth. It's an ethyl because it's connected to the main chain. And on this ethyl that's connected, there's this group, which is a methyl. Where is that methyl found? On carbon 1 of your branch. So that's parentheses 1 dash methyl ethyl parentheses. Isopropyl can be named as isopropyl, or official IUPAC rules say it should be named as 1-methyl ethyl. In this class, we will intermingle between these two, and either one is perfectly acceptable. But isopropyl, remember, is where a little bit of common nomenclature bleeds into other IUPAC nomenclature. All right, let's look at isobutyl. If we highlight the longest chain we can on isobutyl, that's going to be a 3 carbon chain, so it's a propyl. And off of carbon 2 of my propyl is a methyl. That's not legible, that's methyl, 2-methyl propyl. And that thing would be stuck in parentheses, and you would have to provide the number off of the main chain where you can find this 2-methyl propyl outside of the parentheses. All right, keep on trucking. If you look at sec-butyl also has a propyl, but it's a 1-methyl propyl. And finally, tert-butyl, it's an ethyl. It's a 1,1-dimethyl ethyl. So all of these could be named this red name, which is sort of common bleeding into IUPAC, or they can be named strictly with IUPAC rules, which is the blue stuff, except propyl and butyl would be named the same regardless. Normal propyl and normal butyl. Okay, cool. More rules. So you've already seen all these rules. All I'm presenting it for is to show you here's the main chain, and it needs to be numbered this way. And here is the official name. Again, you've already seen the rules, so I'm highlighting the main chain and telling you it needs to be numbered this way to give you that overall name. This one had 1 branch. You could number it either way. It doesn't matter. But I think it's worth pausing for a second to say, what is that group? That group could be named an isobutyl, giving it this name. Or it could be named a 2-methyl propyl. So either one is okay. Since branch substituents give goofy names, if more than one chain competes, choose the one with the most substituents. So if you followed the junction rule here, from this junction, there are 3 carbons in multiple directions. So you're going to have a 7-carbon chain as your overall chain. Note, I added an extra carbon over here versus what's on your actual slides. Sorry about that, it's a typo. So you're going to have 7 carbons on your overall chain, and you choose the overall chain that has the most substituents so that you don't have to name goofy branch substituents. That leads to this being our overall chain, and our chain numbering starts up here to give everybody the lowest number possible. That's what we're always aiming at, the lowest number possible. So this is 3-methyl 4-propyl heptane, not 4-sec-butyl heptane. Those have the same root name, the same parent chain name, but you choose the most substituents possible so that you don't have to name goofy branches. Here's our parent chain, and this one has a weird little thing that you could number it this direction and give your substituents number 3 and 5, or you could name it from the other direction and also give it the numbers 3 and 5. When you can number it either way and give them the same numbers, as a last resort rule, name them alphabetically. So this one should be 3-ethyl 5-methyl heptane rather than 5-ethyl 3-methyl. You alphabetically give the lowest number possible. But this is when all other rules do not decide how to name this thing. Okay, cool. Let's do a quick little drawing of this guy. It is much easier to draw a structure from a name than see a structure and come up with a name, or at least that's my opinion. I'm going to start at the very end. Nonane means 9, so I do 9 carbons. We will give them official numbers so that you can see where I'm at. Let's put an ethyl on carbon 3. That's 2 carbons on carbon 3. There's a whole parentheses thing, so I'm going to go to the end of the parentheses and put a propyl on carbon 5. Propyl means 3 carbons all in a line. And on carbon 5, I'm going to start renumbering my propyl chain because that's what the parentheses tells me to do. Then on the propyl substituent, I'm going to put an ethyl on carbon 1 and a methyl on carbon 1 also. This is my final structure. This is my 3rd time trying to say this name properly. 3-ethyl 5 1-ethyl 1-methyl propyl nonane. Whew, it's a mouthful, but it's not so hard to draw a structure when you're given a name, or at least I hope you think not. So this may be an odd little thing to sneak in here to discuss right now, but I think it's important to discuss types of hydrogens and types of carbons so that we can be sure we're all on the same page as we begin studying more reactions soon. When a carbon is connected to one other carbon group, the rest of the things it's connected to are hydrogens or oxygens or anything that's not carbon. We would call that carbon a primary carbon. This carbon that's connected to one other carbon is a primary carbon. As shown in the figure, hydrogens that are connected to a primary carbon are called primary hydrogens. When a carbon is connected to 2 other carbons, like this one, 2 other carbons, this carbon is a secondary carbon. That secondary is often abbreviated as a 2 with a little degrees sign. Primary is a 1 with a little degrees sign. Connected to 1 carbon, you're a primary carbon. Connected to 2 carbons, you're a secondary carbon. Connected to 3 carbons, you're a tertiary carbon. Connected to 4 carbons, you're a quaternary carbon. I didn't really save myself a lot of room to draw on here, but this carbon is a tertiary carbon because it's connected to 3 other carbons, and that carbon is a quaternary carbon because it's connected to 4 other carbons. Tertiary, that's a 3 with a little degrees. Quaternary, that's a 4 with a little degrees. So you call the carbons certain things based on how many carbons they're connected to. Note, oxygens do not count. Nitrogens do not count. It's only carbons. And then you talk about the hydrogens that are connected. You refer to them based on the type of carbon they're connected to. Primary, secondary, tertiary, quaternary. Know those terms. Okay, so if we hop back to nomenclature for a minute, naming cyclocompounds is not something you've been exposed to previously. Naming a cyclocompound, you have to first figure out, should your parent chain be the cyclo or should it be something else? In this example, the parent should be the cyclo because the parent has 6 carbons while the substituent has 2. In the next example, the parent should be this main chain, this long chain, because it has 7 carbons while the cycle only has 4. So you have to pick who's the better parent based on the number of carbons. So this example on the left is a cyclohexane. Don't forget to put cyclo in the name. It's an ethyl cyclohexane. If you only have one substituent, you don't have to name it 1-ethyl cyclohexane. This one, since the parent will be our long branch, it's a heptane. It's a 2-cyclobutyl heptane. Yep. In the bottom one, where you've got several branches, you're going to name the cyclo as the main chain. And you number it just like before to give everybody the lowest number possible. Because this carbon has 2 substituents on it, that carbon needs to be number 1 because that will give everybody the lowest number possible. So then I could go carbon number 2 over here, or on the other side. There's a substituent on the left, so I'm going to number it toward the left. So it's a cyclohexane. It's a 1,1-dimethyl. It's a 2-propyl and a 5-ethyl. So remember, you're alphabetizing methyl, propyl, and ethyl. So that makes our whole name 5-ethyl, 1,1-dimethyl, 2-propyl, cyclohexane. It's a mouthful, but if you follow all the rules, I believe you can do this.